So lesson 5.1 is nth roots, radicals, and rational exponents. An nth root can be denoted by a radical symbol with an index of n, or in other words, the nth root of c, where c is called the radicand. Okay? We don't have any roots up here, but we'll have some down there. But the idea is some vocabulary here. So an nth root. In other words, this little n. It could be a 2 for a square root. It could be a 3 for a cube root. It could be a 4 for a fourth root. That's what we're talking about here when we talk about nth roots. Okay? See the number under. So first of all, the symbol. If you ever hear me talk about the radical, I'm talking about the square root symbol. Okay? So vocabulary there. Make sure we're on the same track. And then the number under the radical, so the number under the square root symbol is your radicand. Okay, so all good vocabulary to know. Now, in this first section, they're asking us to find all real nth roots. Okay, and we do want to pay special attention to the fact that they're saying all real nth roots. First of all, we're not talking any imaginary numbers in this unit. Okay, so the imaginaries, put those on the back burner. But we want to find all real nth roots. So, thoughts as we look at A. It asks for all real cube roots of 125. What do I mean by cube roots?
Instead of like in with the superscript of 2, it's in with the superscript of 3.
Okay, so we're looking for something raised to the power of 3. That's going to equal 125, yes?
Yeah.
This would be where I said have your calculators at your desk, unless you happen to know it. Cube root of 125. What'd you say, Braden? 5. Now, did you just know that, or how'd you get it?
No, I used the calculator.
You used the calculator, fine. Did you guess and check, or did you use a button? Used a button. Are you guys familiar with the button?
No.
I do not know how to do the cube root.
Okay.
I'm looking at it.
And this is why I'm asking, okay? So, I'm demonstrating with the calculator I have. Some of your calculators are different, yes? You're still looking for the same symbols. You may just have to look differently, and I am more than happy to help you find it. But on these calculators, you can see where I'm always pointing here. But this is my square root, yes?
Yeah.
It's just a regular square root. It would find the square root. It doesn't help me in this case, does it? Because I want to basically know the cube root. And so on this particular calculator, I have, and if you look closely, I believe that is the x root, yes? So I don't have a cube root button on my calculator. You may have it on your calculator, but I don't. So if I want to find the cube root, what I'm going to do is I'm going to start by typing a 3, because I want the cube root. And then I'm going to do that x root symbol. So I'm going to do second and the x root. And so this is saying I'm going to be finding the cube root of whatever I type next. So cube root of 125 is 5. Now, on your calculator, you're looking for some little x root. Did we find it? Did you get it to work? Now, could you have just done 5 times 5 times 5 in a guess and check type manner? You can. And I'm not against guess and check, because can it get you there just as quick sometimes? That's definitely okay. Okay, but the idea here is that we were looking for what number to the third power, which gave us 125. Okay, so our real cube roots are 5 here. And the reason is because 5 times 5 times 5 is 125. Okay, questions or calculator help? Not yet?
So I assume fourth roots is basically the same thing except to the fourth power.
Yep. Okay, so fourth roots, we're looking for the real fourth roots of 16. And again, as I said, it's all real here. Okay, so I'm looking for basically what number raised to the fourth power equals 16. What do you got, Brian?
Wrong.
Dang it. What do you got, Hayden?
2.
2. Okay. Do you guys agree with them? Okay. Either guess and check on your calculator or what I just showed you on the last one. Can you use that X root button? Okay. Now, here's the deal. The calculator doesn't give me all the answers here.
There's more.
There's more.
What the heck?
There's more. So I agree that 2 times 2 times 2 times 2 is 16. Braden? Plus or minus 2. Tell me, guys, what happens if you do 4 negative 2's? What happens when you multiply 4 negatives? You get a positive, yes? So, all of this to say,
If it's an even number, then it can also multiply by negative. Right, yeah.
if it's an even root, is that what you're meaning, Ashley?
Yes. If it's an even
Yep.
root, then the negative will equal the positive as well.
Yeah. Okay, so what Ashley is pointing out, he's heading right in the right direction. This first one was a cube root. Why didn't we say plus or minus 5 here? Because 3 negatives is going to result in a negative. That's not what we are asking. So with an odd root, like a cube root, if you're asking for the cube root of a positive number, you only get a positive answer. Okay? For an even root, if you're asking the even root of a positive number, there's always going to be 2, the positive and the negative. Okay? And I have that summarized over here. Odd roots, so that's like cube roots, fifth roots. Odd roots, there's always going to be 1 real root, and the sign is the same as the base. Okay? Even roots, if it's a positive base, like what we just witnessed, there are 2 real roots, the positive and the negative. If it's a negative base, we're going to say no real roots. Okay? Because otherwise we'd be going into the imaginaries, and that's not what we're being asked to do today. Okay, C. Real fourth roots of 81. 3? Is that it? So 3 to the fourth is 81.
No, but
Could we use a negative?
Yeah, you could also apply the negative.
Yeah. A negative 3 to the fourth is also 81. And again, it's because a fourth root is an even root. When you multiply 4 negatives, it's going to take you back to a positive. So what are my answers here? Plus or minus 3. Okay. And D, real cube roots of 64. What are you coming up with, Olivia? 4. Okay. 4 to the third is 64. Are you guys practicing on the calculators? I hope you are, because that's going to make homework a lot easier, right? If you know how to use the calculator ahead of time. Don't just rely on your classmates to tell you. Do I say plus or minus 4?
No,
Why not?
because it's not even.
Yeah, it's odd. Right here we're talking real cube roots. So my only answer is going to be 4. Okay? Okay, so you have a little chart here to kind of, remind you. Questions? Okay, and again, if something's not working right on the calculator, you're not figuring out how to use your calculator, please ask. Okay, please ask. They're going to be important in this chapter. Okay, bottom half here talks about interpreting fractional exponents. So we just talked about cube roots, cube roots, fourth roots, square roots, fifth roots, they all fit in the same category. Now, here's the deal. We don't always write it as the nth root of x. In algebra, you sometimes see a fraction in the exponents. When we see a fraction in the exponent, so x to the 1 over n, that's the idea of saying the nth root of x. So that number in the denominator, that n in the denominator, tells you what type of root. So if this was x to the 1/2, then this would be the square root of x. Okay? If this was x to the 1/3, this would be the cube root of x. And that's what we'll practice down in this next section here. The extension of this is if your numerator is something other than 1. So if you have x to the m over n, okay? Notice the denominator, the n, goes right here as the radical, or as the index, so it's telling you what root. The numerator m goes over as the power. And we're going to practice that, okay? So your denominator is always telling you what root. Your numerator tells you what power. Okay? Now, the directions here on this first section ask us to explain what each fractional exponent means and then evaluate. I'm not going to do your typical explain because when you guys hear explain, you usually think, okay, I'm going to have to use words. I'm not going to make you use words. I'm just going to ask you to write it in a radical form. So what do we mean when we say 16 to the 1/4 power? What am I asking you to find?
The fourth cube, not cube, the fourth root, whatever.
Okay. So right there, it's a fraction. So I know it's going to be 16 under the radical. This 4 right here tells me we're trying to find the 4th root of 16. Okay, that's what that little 4 tells us, is that we're trying to find the 4th root. Now, it says, then evaluate. Okay, so we explained, we showed it in symbols. Evaluate, that's give me the final answer. What do you think, Emma?
2.
2. Now.
Positive and negative too.
Actually, I'm going to be difficult here.
Oh.
It's only 2. Now, hopefully you guys see what Ashley's trying to say. Does it make sense he's trying to say plus or minus 2? It's a 4th root, it's an even root. Here's the catch, folks.
Well,
In that top section, okay, it just gave me the number, and it said to find all real roots, yes? All real roots can include plus and minus on your even roots, okay? Now, the understanding in math is, in this case, basically the radical is provided, and when the radical is provided, they don't want plus or minus. They just want the positive. If they had wanted a negative here, they would have put a negative sign out front. Okay, so we only want the positive roots here. Sorry, it's a little bit confusing, I know. You're just going to kind of have to commit that to memory. Okay? Okay. B. 25 to the 1/2. What do we mean by 25 to the 1/2? Okay. So 25 goes under the radical. This 2 tells me it is a square root. Now, technically, do I have to write the 2? No, that's square roots is the one time I don't have to do it. Could probably do this one without a calculator. What's the square root of 25?
5.
5. And again, we're just looking for the positive answer here.
Signal.
And I guess in my notes, I do have it written as, maybe I did write a little bit of words in here because I did write it as square root, but I don't have words written on the next two, so. Okay, guys, C. It changes a little bit. 27 to the 2/3 power. What do we mean? What do you think we mean?
Need to get to the third, like, square root. We put 27 in the box.
Okay.
I don't know what I was trying to say.
We're working on the vocabulary. I get it. 27 in the box. What kind of root is this?
Cube.
It is a 3. It is a cube root.
Power 2.
And then that 2, here's the deal. The other ones just had 1, so I ignored them, didn't I? This one has a numerator of 2. So that 2 means we're going to do to the power of 2. Now, I wrote it that way with parentheses, but here's another way I can write it. The other option is you can say the cube root of 27 squared. Indicating it doesn't matter which you do first. Okay? You can do the cube root of 27, get that answer, and then square it. Or you can square 27, get some big number, I don't know what, and then take the cube root of that. It works either way. Me personally on this one, I can do this in my head because I know the cube root of 27, and then I can square that. What's the cube root of 27? 3. And so then if we do 3 squared, what's 3 squared?
6, 9.
9. Getting the wrong answers out of the way now so you don't make mistakes on homework, right?
Yeah.
Now, if someone instead did 27 squared, you got some big number, right? And then you took the cube root of it, what should you have gotten? 9. Okay? And again, if the calculators fail you, let me know and I'll help you figure out where they're going wrong. Okay, one more. 32 to the 2/5. If you got this straight in your head what this means, I'll give you the hint.
32 to the 5th.
Third.
5th to the 32. I don't know what number that is actually. 5, 5th, 5th.
Okay, so where's the 5 go? The 5 is the
Outside.
5th root, yes,
To the power of 2.
to the power of 2. Okay? And again, you can write it either way. You can put the 2 there, or you can say the 5th root of 32 and square that. They do the same. The point is, it doesn't matter which way you go first. You don't have to write both. Write what you want. I personally know the 5th root of 32. It's a good one to learn. You know the 5th root of 32?
5th root 32 is 2.
2.
Yeah, 2, and then just 2 by the second power, which is 4.
4. And again, my question would be, did you get 4 however you did it? Okay, and this is a lesson where I really hope you're not just following along and just writing down what we write down. I hope you're practicing, right? Practicing with your brains, your calculators, whatever it needs. Okay, questions on that section? Getting the hang of it? Okay, so this was just a little bit of the basics, okay? We're still going to keep it kind of basic here, but we're going to throw in a few negatives.
Oh, God.
Now, I'm really not quite sure why I have A in here, but that's all right. 32 to the 3/5.
5 to 30. Wait.
32, 8.
So is it the same thing except the 3?
Uh-huh. That's why I'm like, I really don't know why I have this one in here. It's 32 under the radical. It's going to be the 5th root, and it's going to be raised to the 3rd. Okay, and as I said, I tend to do this. I tend to do the root first, because otherwise, I don't know what 32 to the 3rd is. I'm tied to my calculator then. You know a few of these basic numbers, you're not tied to the calculator. What was the 5th root of 32? 2. 2 to the 3rd is 8. Okay?
Among math ways.
Okay. Now, first of all, can you see it on B?
I see it.
There is a negative. Sometimes the negatives, when I type them,
That's the same one.
they kind of get tied in, don't they?
Yeah, that's the same one.
Realize this is 27 to the negative 2/3. If you see an extended fraction bar, question yourself or question me, is that a negative? Okay? Savas, I don't think they'll be as hard to read, but sometimes my typing, it doesn't show it very well. Okay, guys,
Oh.
before we deal with the 2/3, I have the big question. What do we do with the negative exponent?
You just times it by a -2 at the end.
Nope.
Oh.
Jocks.
Fine.
What do we do with negative exponents? Basically, my question is, How do I get rid of negative exponents?
Yeah.
Just put an I.
Divided by
Erase the line.
negative.
Make it a
I'm not sure if I've heard the right answer or not.
You
Did
just
you hear the
mark
right
it out.
answer in there?
White out.
We just white out.
White.
Whiteout's not the option. We're not talking eyes. I did hear that. We're not talking eyes. In order to get rid of a negative exponent, folks, you move to the denominator.
Oh.
Negative exponents, in order to get rid of negative exponents, you move across the fraction bar. This right now is considered on top. So we're going to move this to the bottom, and we're going to say this is 1 over 27 to the positive 2/3. 1 over 27 to the positive 2/3. So implant this in your head. How do we get rid of negative exponents? We move them across the fraction bar. And I know I'm not the first to teach this to you. I'm not saying you remember, but I know I'm not the first to teach it to you. Negative exponents go to the denominator. Now, from here, can you do 27 to the 2/3 in the denominator?
Yeah.
Yeah, it's no different than what we were doing. It's just now in the denominator. So now it's going to be 1 over. I'll give you the hint. 27 goes in the radical. Where's the 2 go? Where's the 3 go?
The 3 goes on the outside and the 2 goes on the inside. Well, however you write it.
Yeah. Basically, 3 goes out front as the index, as the root, and the 2 goes out back as the power. As long as you know in your head where you're going, that's the important part at this point. Okay, so
You always have to put the 1 over it.
because it was a negative exponent, that's why we put the 1 on top. Okay, so only because there was a negative exponent. That's how we got rid of the negative exponent. What's the cube root of 27? Do we know it?
3.
3. So cube root of 27 is 3. So this is 1 over 3. 3 to the second. And what is 3 to the second? 9. So this answer becomes 1/9.
Must be 9.
It cannot just be 9.
No.
If you have $9 or a ninth of a dollar, is that the same thing?
No.
I hope I don't have a knife in the dollar.
It's a ninth of a
If you get a ninth of a dollar, you just might as well just have no dollar.
You have a few cents in your pocket, right? So you have like 11 cents in your pocket.
Yeah, I don't know how to do money. So.
Okay, so
I have a question.
the point is, negative exponent. What's the only thing it did? It moved to that 9 to the denominator. Okay? And C. The negative of 16 to the 3/4.
1 over.
Is it 1 over this time?
No.
Oh.
Why not? It's not 1 over because this is not a negative exponent. This is just telling me my answer is going to be negative. That negative out front is just saying your answer is going to be negative. Okay? So, what do we know about 16 to the 3/4? It's going to be the what root of 16? The 4th root of 16, because that's the denominator, raised to what power?
3.
The 3rd. What is the 4th root of 16?
2.
2.
Oh wait, actually,
Yes.
I just guessed.
What is 2 to the 3rd?
8.
So what's my final answer?
8.
Negative 8. Okay, that negative out front just carries down. Says my final answer is negative. Okay?
Oh.
Yep, there's a backside.
Probably only a front.
Yeah.
Nope, there's a backside. Now, and I will tell you guys, I forgot to put it up there, but we are scheduled to get through these notes today, and I do have this as homework is due tomorrow. I forgot to write it up there, it appears, but, okay. Okay, 2 more sections. Bottom section, solve the equations, that'll be easy peasy. You'll know what to do there. What we've got to talk about here is what happens when we throw variables in. Okay? What happens when we throw variables? We focused on the numbers. Okay? and you've got the calculator to help you with the numbers. The variables are a slight difference, okay? And what we want to look at here, okay? So the nth root of a to the m, okay? That's the same thing as a to the m over n we were doing on the front. This will make more sense once we get into the problem, but if you have a variable under the radical, okay? If this is an odd root, so like a cube root, a fifth root, then your answer is just as is. If it's an even root, so a square root, a fourth root, a sixth root, okay, so on and so forth, then we have to consider the absolute value of that variable. Because here's the deal. I just talked about on the front side that on these even roots, when you see the radical, a positive answer needs to come out of there. Well, absolute value is the only way we can make sure a variable is positive. Okay, so we'll talk through it as we go. Okay, so we're being asked to simplify each expression. Use absolute value symbols when necessary. That will have to do with variables, and I'll lead you through it when we get there. Thoughts on the fifth root of 32m to the 15th?
Oh my.
Are we intimidated by this one?
It's odd.
Okay, it is odd. It's a fifth root, it's odd, so that means I won't have to consider absolute value at the end. Okay, let me break this up into two pieces. I'm going to rewrite this as the fifth root of 32 and the fifth root of m to the 15th. I'm not saying you have to rewrite it as two pieces. I'm just trying to help here. Now, by doing that, fifth root of 32. Have we done that today?
2.
The fifth root of 32 is 2. Are we okay with that first piece? Now, the fifth root of m to the 15th. Right now, it's displayed as a radical. What power would that be if I get rid of that radical sign and write it with an exponent? That is m to what power? Go backwards from what we've been doing.
M15.
Well, it's m to the 15. Where's the 5 go?
Right there.
But if I'm trying to write this as an exponent,
Plus 3.
it will be here in a moment. How'd you get 3?
I did 5 times 3.
Okay. I was going more for 15 divided by 5.
Well, same thing.
Exactly. I'm with you. I'm with you. Okay. I'm going the reverse way of what we've been doing, right? Now I'm taking it out of the radical and putting it back into the exponent. The 5, that radical of 5, that fifth root, is your denominator. The power of 15 is the numerator. And then I would have asked, what's 15 divided by 5?
3.
3. So what does this clean up to be? 2m to the third. Okay, so basically I took the fifth root of everything under the radical. And I got 2m to the third. Now, I'm going to comment. This was an odd root, yes? Since this was an odd root, basically I'm just going to say, okay, check, we're done. We don't have to consider absolute value. We'll talk about what has to happen when it's an even root when that appears. Okay, questions there?
No.
Okay, let's try B. B is the fourth root of x to the 20th, y to the 8th. Do you want me to split it up as two separates?
Yes.
No, you don't have to, but just realize this is the 4th root of x to the 20th times the 4th root of y to the 8th.
I look at that and I fear I'm lost.
So it's x to the 5th times y to the 2nd.
Now, what did you say, Jocelyn?
I fear I'm very lost. I don't know what I'm looking at.
Are you okay with what I did here? All I did is I took the two things under the radical and split it into two radicals. Okay, that's all I did right there. Not trying to be fancy. Now, take these out of radical form and go to the fraction exponent. And here's the deal. You got a 50-50 shot with the fraction exponent. It's either 4 over 20 or 20 over 4. Well, where's that 4 go? The 4 goes in the bottom,
20 over 4.
so 20 over 4. Do the same thing with the y. It's either 4 over 8 or 8 over 4.
I feel like we talked about this sometime, or like last year we did with Rogers.
It's possible. I'm not saying I'm the first that's taught you this. I do feel like it comes up in Algebra 1 a little bit. Okay, clean this up. What's it become?
X5 and Y2.
Now, I kind of got sidetracked in there and forgot to mention something. So we've got to go back and talk about it now.
So you just drop the multiplication sign.
Yeah, you don't have to have the multiplication sign. What type of root was this?
Even.
This is an even root. Because it's an even root, right here, if it's even, we have to consider absolute value. So what we have to do here is we have to put absolute value around this problem. Now, however, we don't want to put too much absolute value, if that makes sense. Like Savas will get mad if you put absolute value where it's not needed. So here's the deal. And I will too. I mean, I don't want it where it's not needed. We're considering absolute value. The key is absolute value does what to something? It makes it positive. Okay? X to the 5th. Could x to the 5th be negative? If x is negative, what happens when you do a negative 5 times?
Negative.
It's a negative. X to the 5th, that needs the absolute value. So we're going to keep the absolute value there. Y to the 2nd. If y was negative, what happens when you square a negative, though?
The positive.
It becomes positive. So does y squared need absolute value to make it absolute value? No. Anything squared is automatically positive. So I'm going to write my final answer as the absolute value of x to the 5th times y to the 2nd. And that y to the 2nd is outside the absolute value because I don't need it to keep it positive. Okay? Am I making sense here?
Makes sense.
Okay. Okay, let's try C. Cube root of negative 8, a to the 3rd, b to the 9th. Again, not saying you have to, but can you break this into pieces if it helps? We're going to have the cube root of negative 8, the cube root of a to the 3rd, and the cube root of b to the 9th. I did that without explanation. Does it make sense I split it into 3?
Yeah.
Do you see 3 things? 3 pieces? Okay. Cube root of negative 8. Okay, what's the cube root of 8?
2.
Cube root of 8 is 2. What's the cube root of negative 8? Negative 2, because 3 negatives are going to multiply to be a negative. So this is negative 2. Okay. The cube root of a to the 3rd. Well, how do we write that exponent? Is it 3 over 3 or 3 over 3?
Might just be
3 over 3.
It's 3 over 3. What is 3 over 3 going to simplify to?
3.
A to the first. Okay, we'll do that next. And B. Now, okay, here it matters. Is it 3 over 9 or 9 over 3?
9 over 3.
9 over 3.
That's 3.
I'll agree there. Okay, clean this up. Negative 2, A to the first, or just A, B to the third. Now, do I need to consider absolute value?
No, it's not. It's odd.
Well, no, I circled the answer, but it's odd, so we checked, we're good. Okay. Quickly, we're doing what? The fourth root of 256, the fourth root of x to the 12th, and the fourth root of y to the 24th. Bigger number. What's the fourth root of 256? You have a calculator, right?
4.
It is 4. X to the 4 over 12 or 12 over 4? 12 over 4. Y to the 4 over 24 or 24 over 4?
24 over 4.
24 over 4. Now, so we have 4. We have x to the third, y to the sixth. Do I need to consider absolute value?
Yeah.
This was an even root. Because it's an even root, we're throwing on absolute value bars. Now, my style of teaching, I throw on the absolute value bars. And then I say, okay, where do I need the absolute value? Does 4 need absolute value to be positive?
No.
No, it's already positive. X to the third. Does it need absolute value to keep it positive? It could, because what happens if x is negative? A negative 3 times is still a negative. Does y to the 6th need absolute value to keep it positive? No. Anything to the 6th root will be positive. Now, I wrote that as 4, absolute value of x to the third, y to the 6th. Did you catch my shortcut here? Basically, what needs absolute value in these scenarios? The odd powers, right? Now, I know the bell's getting ready to ring on me, but I promise you, you can pick up on this last section in the last 2 minutes of class. So, real quick, it's solving the equation. 2x to the 5th equals 64. Basic equation solving. How do I get the x by itself? Divide by 2, yes? Pretty basic. X to the 5th equals 32. How do I get x to the 5th to become x?
You had the square root.
Not the square root, but the 5th root. Now, hey guys, guess what the 5th root of x to the 5th is? Well, that's x. The 5th root of 32 is 2.
Okay.
What about 5x to the 3rd equals 320? Divide by 5. Thank you. I was wondering what that was going to be. X to the 3rd equals 64. What do we do this time?
Cube root.
We do the cube root. What's the cube root of 64? 4. Now, last one, guys. Hang with me. You know to tell me to divide by 2, right? P to the 4th equals 81. You know to tell me what root are we going to take? The 4th root. Now, there's a catch. First of all, what is the 4th root of 81?
3.
3.
Oh, yeah.
What happens when you take a square root in an equation setting? What do I always tell you? Plus or minus. What did we just take?
Cube.
A 4th root. What do we need? Plus or minus. So when do you have to use plus or minus?
Even.
Even roots. Okay, guys. You have homework in Savas. It's due tomorrow. Start this semester off strong, please. Okay, get in there, get it done. I know there's like 20 questions, but some of them go very quickly like this. I mean, think about what we did here.